For the first day, you had domain, range, increasing, decreasing. Did we talk about positive and negative as well in your class? And I apologize that I have to ask, but I know we did in math 4. So I don't want to talk about something that's not pertinent. But either way, it's coming. If it's not now, it'll be later. So domain and range is as basic as it was in Math 1. It's been a little while maybe for some of you. So what I usually do, if you don't have Post-it notes, hopefully you have index cards or something of that nature, you would need to, for some people, close off what you can't, like what's not there. But you do want to see your y-axis and your x-axis. So your domain and range. So in this case, it does have arrows at the end. The video, the teacher, I think it was day 2 that I posted, she's awesome. Loved her video. It was a little longer, but her personality made it seem a lot less because I have an attention span of a squirrel. So if I can watch it, anybody can watch it. So your domain in this case is left and right. So that's your x values always x values. With these arrows, that means it's going to go left and right forever. So you can do all real numbers. That's a symbol for all real numbers. You could also write from negative infinity to positive infinity and put an X, small number to the left, small number to the right, larger number to the right. Then you always use less than symbols. I'm not sure which video, but one of the teachers did call that out as well to make it a little bit easier. And so then that's going to be parentheses to parentheses because it is indefinite. Like you can't stand on a infinity. Like, so if it was a closed circle, then it would be a bracket, which is that, because then it stops right there. It is there. You stand on it. That enclosed circle, solid circle is a thing. If it was an open circle, so just like a dot, they'll notate it sort of like that, then it would be a parentheses again because you can't stand in a hole. So domain for this guy. Then range. Range is your up and down. So you're thinking your y values for range. So I'm going to get rid of this because this is left and right. So range is looking up and down. So how far up does it go? And those arrows let you know that it's going to go forever. And this is positive infinity up here. Down at the bottom is going to be your negative infinity. So range is y values always. And so it's going to go from 0, because this is where it stops. So 0 to positive infinity. So you could do it this way. And the notational differences are just depending on the teacher, person who taught you before, depending on the program you're using, whether it be IXL or Delta Math or Canvas or SchoolNet or EOC. You just want to pay attention to their different styles of notations. But you could also do y is greater than or equal to 0. And then that would just be a parentheses notation because that's not necessarily setting boundaries. That's just stating that it's everything from 0 and up. So that's your domain and range. Does anybody have a hard pressing question about domain and range at this point? Because if not, I'm going to go ahead and move on to positive, negative. 10 seconds to pop in a question. Thanks, Robert. Appreciate that. Okay, so positive and negative. See if I can pick a good one. I'm going to crawl over here to the third graph because of where the intersections of things are. So positive is up here. So positive, increasing, yes, make sure I'm using all the right words. Positive is above the x-axis. So everything above the x-axis. For domain is x, range is y. The only thing you're going to use y values for are max, mins, and range. So y value, your up and down axis is only for range, at max, min values. That's it. Other than that, you are always looking left and right. So all of these, you'll see them written, and they'll use the word intervals. It's intervals, but I also think of it as little tiny domains. So at this point, if I want to know when is it positive, it's talking about at what x value, and you want to look at like where it touches the x-axis because that's where it crosses into the upper versus the lower quadrants. And so you're negative down here at the bottom. But if we're talking about just positive, And some classes I've made them go through and use highlighters, and you can highlight the top of the graph and you can highlight the bottom of the graph. So like this whole part is all your negative, and then obviously the upper half is all your positive. Again, so you're looking at when that graph lives in that area. So this graph is only positive right here at 3. 1, 2, 3. And then infinitely from that point on. So it would be positive, and you want to use a parentheses because it's not necessarily positive at 0. It's just sitting on the line. It's crossing the line. So from 3 to positive infinity. Or you can say when all values are greater than 3. So x is greater than 3. And that's your positive interval. Now, negative is the same idea. So you want to go from the left, start reading from the left. And that's our negative infinity over here. And there is that arrow, which means it's going infinitely in that direction, down and to the left. So negative, this never crossed over the line. So all of the rest of our graph is in the bottom half. So that means we know it's from negative infinity. But it hits 3, and then it crosses into positive land. So then that's it. So it can be written in this form. And again, these are going to be parentheses because at 3, it is not actually positive or negative. It's at 0. Or you can write all values smaller than 3. So x is less than 3. It's not equal to, because again, at 3, it is not negative. It's 0 at 3. Let's see if I can do another one that crosses a couple places. If I look at this one, the second one, I'm gonna draw these dots as if they're in this beautiful place of like negative 3 and positive 3. So again, looking at the bottom, this is where it's negative. And then the upper half is where it's positive. I don't think the green showed up at all, so I'm going to go with purple this time. So this is where it's positive. And you're looking where it crosses at the x-axis because you're only focused on your x-axis for these things. So in this case, positive, it's positive over here, and there's an arrow. It's positive over here, there's an arrow. So from negative infinity to negative 3, it's positive. And then from positive 3 to positive infinity. And your other notation would be all values less than negative 3. So x is less than negative 3. And then all values where x is greater than 3. And I believe it was on Delta Math they used the union symbol because it's both. So it's positive either here or and in both places. And then where is it negative? That's below. So that's when your x, again, only x values because you're setting up many domains. So from negative 3, and then we're going to go to the right, x is greater than negative 3, to positive 3. Or, actually, I think that is the only way you can write that one. You can't write it the other way because it's in the middle between those two numbers is where it's negative. So positive and negative. You're just looking at the top of the graph, so quadrant 1 and quadrant 2, and then negative is going to be quadrant 3 and quadrant 4. Increasing and decreasing was a call out I didn't hear from anybody this week, but it has been in the past something that people aren't really strong at anymore apparently. I'm going to use graph number 5, the 5th one, because it has good turning points on good numbers. So this is where you think about which direction it's going in. You're reading from left to right. And so hopefully, negative infinity, positive infinity, negative infinity. I remember having some students being like, oh, that's what that means. If you're not really fluid and comfortable with that, I would write that at every time you get your hands on a graph. So if I'm reading from left to right, though this arrow is going up, you are looking at like positive, negative lines. So think back to Math 1 when you had just straight lines. If this was a straight line and it didn't curve, this is going down. And then this is going down. but in the middle, we're going up. Again, we are not using y values. That is the biggest thing people do, is you jump on that y-axis where it crossed there at negative 4, and they'll use that number. And can I tell you, if it's a multiple choice question, 110% that number is going to be there, because they know that is your misconception. That is an obvious misconception. In some classes, again, we have, I use green. Why did I do that to myself again? I have made people color like from like turn point. So these are our decreasing domains. And then this is our increasing, because from turn point to turn point, it's going up. And it has helped some students stay away from your y values, because it doesn't touch on a y. It has to touch on the x. So we are decreasing from negative infinity to 0, or all values smaller than 0. So x is less than 0 works as well. And an increasing and decreasing, again, you can't use brackets, because at that turn point, it's not increasing or decreasing. It's basically turning. Like, it is a change of direction. It is standing still at that turn point and then moves. So that's why you're going to use your parentheses and not actual brackets, because in that exact spot, it is not decreasing or increasing. And then also, it also decreases from 2 to positive infinity, or all values greater than 2. And you don't use an equal to, because again, at that point, it is not increasing or decreasing. It is just, it's turning. It's changing its direction. And sorry, I just realized I'm off the screen. So that's our decreasing. And then our increasing, which in this case is our purple highlighted. So increasing is from 0 to 2. So 0 to positive 2 is when it's going up. And then that one you can't write in this case, because it is a between these two numbers. Those x values only between those two numbers. And then again, you're not using equal to, because at 0, it is like you turned on a dime and turned. At 2, you turned on a dime. So it's not actually moving up or actually going down. For increasing and decreasing, for quadratics, I try to give at least one of those, because I feel like if what I just said didn't make sense, you've had a lot of practice with quadratics. It's going to go increasing first if I'm looking left to right. It's a positive line. And then it's going to decrease. And so again, at that turn point, if you are to shade, in one of the videos, I believe, that was walking you through the delta math stuff, they did that. They actually shaded through, which I thought was really awesome. And then all of this is increasing. So then for this one, our increase is from negative infinity, and we're comparing it to positive infinity. So from negative infinity to 3, or all values smaller than 3. Both of those notations are correct for increase on that one. And then decrease is going to be from positive 3. It's when all values are greater than 3. So from 3 to positive infinity is the other way that can be written. And I'm showing you both ways again, because we're in a virtual format, and depending on whose video you watch, if you go look for extra help, or who you talk to, who you had before me, because now you've had 2 really good math classes, at least, if not 3, they've all done it different, or potentially they could all do it different, and it's absolutely correct. So my challenge to you as well in a Math 3 class is you have to ask questions. If I say something different than your other teacher, somewhere along in the survey on Monday, a lot of people asked, is there a way, can you say things differently than someone else if I don't understand? 110%, absolutely, but you have to ask me, because if not, I'm just going to say it the way I say it. That was really brief. Does anyone have a question about increasing, decreasing, positive, negative, domain, or range that I can iron out for, like right now for you?
On that last one you just did,
Yes.
that's in quadrant 4, which would be Oh wait, never mind. My question's dumb. I'll take it back.
It's not dumb. It's perfect. I want you to ask it. Okay, so please, number one, especially for the very few of you that are willing.
I explained it to myself. That's why.
Oh, excellent. Okay, yeah. Excellent. Okay. Yes. So the quadrant 4 thing necessarily for increase and decrease doesn't matter, because that would be, again, and honestly, not dumb question, because you just did exactly, and I celebrate this, because the sooner you mess up and the sooner you do it, or like you just said, like you said it out loud and then you're like, oh yeah, duh, then the better, because then that means you've already fixed it. So saying it out loud is great. But that was, again, you focusing quadrant 4, quadrant 3 is, again, looking at y-axis. So because you're talking about it being negative down in the bottom. If we were asking for positive negativity, like positive instead of increase and decrease, then it would be, you would really be paying attention to that quadrant 4, which I think is what you were going in that direction. So I would say also for math 3, especially in this, that is going to be one of those things where you just have to slow down. If I talk to you every day, you would get so tired of hearing me say, like, you just stop. Read the question, answer it, don't move on, read the question again. Because you have so much math in those beautiful little brains at this point, you will answer it wrong because you will think it is asking for something else, which you may have done prior to now. But now you really have a lot of high school math floating around in your domes, and you have to be able to pull out what you need for this question. And that skill is really, it sums up to slowing down. Because most of you know exactly what I'm talking about. You just get frustrated and mentally talk yourself out of the game. Or like I said, my favorite analogy is you run to the deep end and you jump in with no swimmies and you have no idea what's going on. And you had no idea it was a 20-foot pool. So just slow down. Perfect. Great, though, Robert. Thank you for even, like I said, noise is amazing. So moving forward, your parent functions. I got a lot of texts and a lot of emails about people panicking over parent functions. The only reason we did parent function is, one, you need to know they exist. Because we are going to do transformations. I'm a huge fan for EOC courses. At walking into the EOC, knowing you're going to have questions in your pocket that you know you're going to get right. The cool but really, really crappy part about an EOC, because like I said, some of you probably didn't even take the Math 1. Gratefully, please be very grateful. That bugger is really bad. Math 3 EOC is really straightforward. It's the math we are doing, and they ask the questions. And most of the questions we ask in our class are going to be very similar. Now, can I guarantee all of them? No. But transformations is a big chance you're going to see one. So the different functions is where their range of getting to throw whatever they want at you is using which function. So whether it be a quadratic, an absolute value, cubic, or square root. I thought this table was pretty nice. Maybe to cut out, put in your notebook, or if you print the whole thing, that's perfect too. Just highlight through it. Because if you look at it's kind of like the formula, the rule, the outline is what I like to call it for each function. They're really the same. So if you can find a home for those letters in your brain, they all control the same thing no matter the function. So for the quadratic, your H value is still going to control the left, right. It is going to be HK is going to be a vertex, much like the absolute value. An absolute value function is newer to you and is the one that Math 3 questions focus on. We're about to jump all into absolute value functions. I have had students say they've had some exposure to it before, but that's where we're going to go. That's going to be your focus, because your other 3 should have been focused on in Math 2. So we're really adding absolute value in there. But again, take away your parentheses and your square, and it's the same thing. It's just bars. So hopefully we know that absolute value means you can only have outputs that are positive at that rate for it to be within those absolute value bars, because absolute value bars means no matter what's going on in the middle, it's going to be positive when you do the calculations algebraically. And that's just a definition thing. But they should, hopefully you see the pattern. A is on the outside of your X, or your, in this case, radical. H is going to be inside by addition or subtraction, depending on if that's a positive or negative value. K is always going to be outside. Now, A, H, and K are not the only letters that I've ever seen on the internet that they use. So just know the variable or number that is in the front by multiplication is your A. So that is going to control vertical stretches and compressions. And I hate that I can't show you my screen and you see my hands. When I say stretch, so I always think about quadratic because I feel like that's what we've done and beaten our heads for the last 2 years. So if I take a quadratic and I grab the 2 legs at the top and the bottom, so your minimum, because I always think about a positive quadratic first, and I pull it up and down, so I stretch it vertically up and down, it's going to get really skinny. If I compress it, so I push it, squish it from the bottom and squish it from the top. So if I compress it, see if this even works, compress it this way, he's going to bow out and get kind of fat. So that's what A controls, especially when it's on the outside. There are vertical compressions, and there's also horizontal compressions and pulls. And they really theoretically look exactly the same on a graph. I think it's in your activity for today. I wrote it in the notes. Maybe I didn't. Maybe I decided to wait till Monday. But either way, don't sweat it. The idea is, does it get skinnier, like more steep, or does it get less steep and wider would be what A would control. H is just sliding left and right. I will say the call out, though, is that your form is a negative right there. So because that form is negative, if I plug in a negative number, which should move it to the left, then the equation is going to read a plus. So in a minute, when we look at some examples, hopefully one's there, I'll call out my rule in my head. I make a lot of rules in my brain to make things stick that aren't mathematical. But this chart will be very helpful, especially like for your midterm, because you would be able to have it in front of you. So looking at the different functions and then the parent function. So as far as your parent functions and everybody panicked, all I need you to know is that this is a square root function. This is a squared function, so it's a quadratic. So that's as far as you really have, like in depth wise, this is a quadratic. Our test is on a computer, so you're not going to necessarily have to make a table. You may have to identify a table, which is why I had you do that in Desmos and match them. But you've done that in Math 1 as well. So again, that's a throwback skill that you should just have in your pocket in case. Absolute value bars. So this is an absolute value parent function. A radical. So this is a square root function. Also known as radical function. And that's just a vocabulary difference. Again, depending on what teacher you had, what worksheet you read, what book you read, what video, things of that nature. This one says to the third power, so this is a cubic function. So if you are sweating your parent functions, I really just need you to know they exist and be able to know like what that is when you see it. Not that you have to be able to graph it by hand or anything wild. So looking at translations, let's see if I can make this show up at the same time. So close. That first one is your quadratic. There are no parentheses. So that is x squared. That squared is with the x. So not on the outside, like down here. So that means that 10 is a k value. It's on the outside of the parentheses. Because for a quadratic, for it to move left and right, it would have to be a set of parentheses, and you have a plus or minus with inside to move it left or right. So that means that negative 10 is going to go down 10. Your absolute value, that is inside the absolute value. So that's your H value, which does control left and right. So then it is going to, it says plus 2 though. That plus 2 means that it was a negative. So it's going to go to the left, about right down, left 2. Because x plus 2, and this is one thing you can always do as well for this one, subtract from both sides. So the x value is going to be negative 2 in that guy, because that's what changed it to a plus. The other way it could have been written, just so you understand why, is minus. But as you know, since maybe 8th grade, if not before, you don't write minus a negative. It turns into a positive. That makes it an addition sign. Now, looking at our radical or square root function, there's a lot of things going on. So we have minus a 1. Then we get outside of our radical, outside, and then plus 6. So that's x minus h plus k is our outline or our rule. So since it's minus, then that means we plugged in a positive 1 because the minus stayed the same, which means it's going to go to the right 1. And I jumped to this. This is your lesson for today, but it's huge. If you can get it, it's just a pattern. So I'm trying to like inundate you with this because we can't spend a ton of days on it, but it's very, very important to the end of the semester game. So plus k, so it's going to be up 6 because k goes up and down. So h is left and right. K is up and down. I would write that on a Post-it note and put it somewhere maybe, if it's not something that's going to stick for you super easy. So cubic function x minus h cubed plus k is how that outline is again. So then I have a minus minus, still a thing. So the h value again, plugged in, had to be a positive 4 because it left it a negative. So that means we went to the right 4, and then we went down 5 because it's minus 5. Now, in my brain, when I was talking about what I make up for myself to make it make sense, whatever I think this is going to do, because all of you for a little while are going to say this is left 4 because it's minus 4, and that makes sense because it's a negative 4. But we forget that the outline looks like this. So in my mind and in my box, whatever I initially jump and think is the opposite. So whatever it looks like is the opposite. So minus, most brains are going to think left. So I'm going to stop myself and go, ugh, they're so ridiculous. And I know it's going to go right. Minus, again, my initial thought would be left, but I'm not right. It is right. Plus, your initial thought usually is to say right. Don't watch it. It goes left. Stupid story that I used to tell in my classroom for these guys, for H versus K. Within the parentheses, absolute value bar, or within the radical, thinking of it as a bag, and then you drop a cat in the bag, right? So you put a cat in a bag and you squeeze it closed, like a big duffel bag. Do you think the cat is going to go in the direction you are planning for it to go? And if you do, that's really cute. But if you've ever played with any sort of cat or watched any cat video, they're absolutely unpredictable, especially if they freak out. So once it goes within those parentheses or in the bag, it's going to do the opposite of what you thought it was going to do. When it's hanging out on the outside, otherwise known as our K value, it does exactly what you would think it would do. So plus 6 is going to go up. Minus 5 is going to go down. So cat just hanging out, happy as can be. I mean, he's just chilling. So he's going to probably go up or he's going to go down like you tell, like it's supposed to. Versus dropping it in a bag and holding it. It's going to go all different ways, not the way you want it to go. Again, really silly, stupid story. Might work for some of you. Again, I am not a hugely math-minded human naturally, so I make up lots of weird things to make things in patterns stick. All right, so absolute value, like I said, that's our biggest focus for Math 3. So all of those other conversations, you will see some of them. I usually lean towards quadratic, again, to be kind, because you've done a lot of quadratic work. Radicals, probably when we get to radical equations, I will throw in some of those just to remind you, because of course the state likes the ones that are the most uncomfortable. And for a lot of people, radical equations are uncomfortable because you pretty much only did them in Math 2. So you haven't had as much exposure to them. But absolute value is our focus. So transformations. I don't know why for the last 5 semesters on any test question that I say list the transformations, everyone shuts down. So all 9 of you right now, hear me. When it says, what are the transformations that happen to this function? You are writing a list of what happened. And mentally, what you should be thinking is A value, H value, K value. Also, you want to think positive or negative, because that's going to flip. So the A value in the front, it's not actually the A value. It is literally a positive negative sign. So did it go up or down? Is it compressed or stretched? Did it go left or right? Did it go up and down? I'm sorry. The first up and down would be more like a flip over the x-axis. So like a happy smiley face, quadratic, sad face, positive to negative. So flip would be your positive, negative. A would be more steep, less steep. H is slide left and right. K is slide up and down. And if you make that mental checklist for everyone you walk into, you won't mess up. So those of that did not come to this class, I cannot wait to see if they do as most other students. But what is the transformations means literally tell me what happened to this graph. So our form for absolute value again is x minus h plus k. Sorry, there's an a in the front. This has no a. So it didn't get more compressed. It didn't vertically stretch or vertically compress or horizontally stretch or horizontally compress. There's not a negative in the front. So it didn't go from a happy V like a bird nose to a mountain and flip over. So we know that's good. That 2 is inside the absolute value bar. So that is our H. It's minus minus. So that's the cat in the bag. So it's going to go right 2. Then there's nothing on the outside. So that's it. That is the transformation for that first function. It went to the right 2. If you look at number 2, so y equals a, absolute value x minus h plus k. There's not an A value. There's not a negative. So it didn't reflect over the x-axis. It didn't get more steep or less steep. And then there's nothing inside the absolute value bars to go left or right. But there is a +3 on the outside. So it went up 3. I've gone over the 30 minutes. So if any of you have to bolt or you've got this nailed, you absolutely can go out. But for the sake of video and you printed this, I'm going to go over the last 4. And then I'll wrap it up. Number 3. Y equals A, X minus H plus K, again, is our outline. In this case, there is an A. So that's going to be steeper. Now, steeper by 2. So another silly story for the number in the front. So my magical world, where I would like to live, is the more cheeseburgers I eat, the better I look, the skinnier I look, the more svelte I am. Okay, that is how this works. So the more cheeseburgers, 1 cheeseburger, 2 cheeseburger, 3 cheeseburger, 10 cheeseburgers, these graphs are going to get skinnier. So they're going to vertically stretch. So they'll get more peaked, steeper, because it would be an up 2 over 1, up 2 over 1, up 2 over 1 is what that 2 does. Now, if there's a 1/2 in the front, there can't be anything below 0. Rule still applies. So if it's -2, it's still very steep, but it's just facing down. It just flips down. But from 0 to 1, there's fractions. So if I eat 1/2 a cheeseburger, if I eat 1/3 of a cheeseburger, or 0.75 of a cheeseburger, 3/4 of a cheeseburger, then it actually compresses and gets wider. And that's because, again, your rate of change means if I go 1, 2, 1, 2, 1, 2, it pushes that absolute value function to be wider. So my line in my class is, my world, I get to eat all the cheeseburgers and I stay very skinny. If I eat less and don't clean my plate, I get fat. So I learned to eat all my cheeseburgers. That's my story. Again, silly, but it works for me. So steeper by 2, which is going to be a vertical stretch. And that's because I grabbed here and I grabbed here and I pulled up to make it skinnier or more steep. And then X minus H, but this is a +3. So we know this is an H value. So that means it's actually a negative, because negative gives me that plus, which means it's going to go to the left 3. When you are looking at graphs, it will be helpful for you to remember that HK is your vertex. So if you're looking at where did it go on the graph, I know that my H value is -3 and my K value is 0, so it's non-existent. So I know that point for my absolute value function is going to be sitting at -3, 0. Because that -3 is what turned that minus into a plus. So number 4, again, you got A, X minus H plus K. That A value is a 3. More cheeseburgers, so I got more steep. So it vertically stretched. So vertical stretch by 3 units is some ways you'll see it written. So by 3 units. But the rate of change is more steep. It's steeper. Rise 3, run 1, rise 3, run 1, which we'll get into looking at graphs next week. And then there's no H and there's no K, so we're good for that guy. Number 5, A, X minus H plus K. Now, there's that minus. So that means that this, I want to call it a parabola, absolute value, instead of going like this, turns into one of those. Just like a quadratic equation. Instead of a positive, it becomes a negative because there's a negative in the front. So we're going to say that first thing it did is flip over the x-axis. Because it went from the positive quadrants to the negatives, just as a parent function, because your parent function would be sitting right here. Then that 2 means it's going to vertical stretch. So steeper by 2 units. Plus 3 means I put in a -3 because it should be a minus for our outline, right? -3, so that means I went left 3 units. And then -1 means it goes down 1 unit. And that's the K. In this case, our new transformation versus your parent function, and your parent function is just y equals absolute value x. So if that was in black, and we would maybe graph this in red, the vertex would be sitting at -3, -1. on your graph. So you could trace your vertex down and plug those things in, count your rise and run, and then you'd have your A value, and then hopefully you will have to decide that it flipped over to get the negative in the front if you have to identify equation from a graph. A, x minus h plus k. So A, there's no positive negative, so it did not reflect over the x or flip over the x-axis. A is 2, so it is going to get steeper again. Vertical stretch by 2 units. That's our A. H, it's not a negative in that equation anymore, it's a positive, so that means it's negative 8 is the H value, which means it went left 8 units. And there's not a K value, so it didn't slide up and down. Your vertex at that point is going to be negative 8, 0. So if you go hunting for that parabola, it should be sitting at negative 8, 0 at the bottom. That is all for that page. Is anyone in a hurry? Because there are a couple more, and I'll finish them if you want. There's nothing I need to tell you other than that, though. So if you need to boogie, like I said, by all means, enjoy your day. Have a great weekend if you don't hang out. This is writing the equation. So I have my parent function flipped vertically, which means it's going to go down. So flipped over the x-axis. That means I know I'm going to have a negative. It doesn't say anything about getting steeper or less steep. So that means I can go ahead and start my absolute value. X, it says shifted up. So that means nothing went left and right. And then up 3 units. Squeezed vertically, which means it's going to go push down. That's going to be your compression. So compression is the other word. That means it's going to get smaller by a factor of 2. Which that one is not going to, we're going to disregard this one. This wording is different, not a good Math 3 worksheet. This is what I was talking about your vertex. So 1, 2, I'm sorry, that's 2, 2. My rate of change is 1, 1, 1, 1. So there's no A value. It's still positive. So y equals no A value, x. It went to the right 2. So that's going to be minus 2 and then up 2, plus 2. Vertex is 0, 0. My rate of change is up 2 over 1, up 2 over 1. It did not flip over the x, so it did get steeper than an average parent function, so it went up by 2. X, it did not go left or right, and did not go up or down. Vertex, negative 3, negative 1. Count my rate of change, 1, 2, 1, 2, 1, 2. It did flip over. This is negative. So we know it's going to be a negative because it's no longer the bird's beak. It's a mountain. So negative. My rate of change is 1 to 2. X. It went to the left 3. So that means that's minus minus, which makes that a plus 3. And then down 1. So overall, that was everything. And that, like I said, that was a little extra. But I know we don't have another live. Actually, I'm telling you a story. We have a live class on Monday.